Right now, when you look up at the night sky, you are being lied to. Your eyes are deceiving you. By all laws of logic, that dark, empty void should not exist. If our universe is truly infinite and filled with an endless number of stars, then every single direction you look should end at the blinding surface of a star. The entire sky should be a glowing, white-hot dome of unimaginable brightness. So where is all the light? Today, we are going to unravel one of the most profound mysteries of our existence, because the darkness above you is not an empty void. The sky is actually blazing with light right this very second, and you are simply blind to it. This baffling contradiction isn't a new thought. It's famously known as Olbers Paradox, named after the 19th century German astronomer Heinrich Olbers. He proposed a very simple yet devastatingly logical idea. If the universe is truly infinite in size, infinitely old, and completely static, then it shouldn't matter where you look. Every single line of sight should eventually end on the surface of a star. To understand how crazy this is, imagine you are standing in the middle of an infinite forest. No matter which direction you turn your head, your line of sight will eventually hit a tree trunk. Even if some trees are incredibly far away, there are so many of them that there is no empty space left to see. The entire horizon is a solid wall of bark. Now, apply that exact same logic to the cosmos. If you pick any random tiny black speck in the night sky and zoom in deep enough, infinitely far, you are guaranteed to hit a star. Because there are infinite stars, the entire sky should be completely paved with starlight. There shouldn't be a single patch of darkness. Nighttime on Earth should literally be as scorchingly bright as looking directly into the surface of the sun. But you don't instantly burst into flames when you step outside at midnight. So where did our logic go wrong? What is hiding the light? Your brain immediately tries to solve this with common sense. You might think, well, obviously, space is full of cosmic dust and black holes blocking the light. It sounds perfectly reasonable, but physics says no. Here's the problem with the space dust theory. If the universe is infinite and has been around forever, those clouds of dust would have been absorbing starlight for an eternity. The laws of thermodynamics dictate that they couldn't just hold that energy forever. They would eventually heat up and glow exactly as bright as the stars themselves. The dust wouldn't block the light, it would become the light. Okay, what about distance? A star that is 1 billion light years away is going to be incredibly faint, right? Yes, individual stars get dimmer the further away they are. Their brightness drops by the square of the distance. However, geometry throws a wrench into this. As you look further out, the volume of space you are observing increases. The number of stars in that larger volume increases by the exact same proportion, the square of the distance. The dimming of a single star is perfectly canceled out by the sheer overwhelming number of new stars. The total amount of light reaching you remains completely constant. Distance does not save you from the blinding light. So, if dust can't hide it and distance can't fade it, there must be a fundamental flaw in how we understand the universe itself. To find the real answer, we have to destroy one of Olbers' fundamental assumptions. He believed the universe was infinitely old, meaning it had simply existed forever. But it hasn't. Our universe had a definitive beginning. About 13.8 billion years ago, the Big Bang set the clock ticking. This singular fact changes absolutely everything, especially when you pair it with the ultimate speed limit of reality, the speed of light. Light is unimaginably fast, traveling at roughly 186,000 miles per second. But it is not instantaneous. It takes time for light to travel across the vast, empty stretches of space. When you look at the sun, you are seeing it as it was 8 minutes ago. When you look at the next closest star, Proxima Centauri, you are seeing it as it was over 4 years ago. You are literally looking back in time. Now scale this up to the entire universe. Because the cosmos is only 13.8 billion years old, we can only see objects whose light has had enough time to reach us since the beginning. This creates an invisible bubble around Earth called the observable universe. If there is a star located 15 billion light-years away, its light simply hasn't had enough time to make the journey to your eyes yet. It is out there, shining brilliantly, but its light is still racing through the dark, trying to catch up to the present moment. In an incredible twist of history, the first person to correctly propose this mind-bending solution wasn't even a professional astronomer. It was the famous horror writer Edgar Allan Poe. In his 1848 essay titled Eureka, Poe realized that if the succession of stars was endless, the background of the sky would present us with a uniform luminosity. The only way we could understand the voids, he argued, was by assuming the distance of the invisible background is so immense that no ray of light from it has yet been able to reach us at all. The poet beat the physicists to the punch. But wait, if time is the only issue, does that mean if we just wait long enough, say another 100 billion years, the light from every single distant star will finally arrive and the night sky will burst into a blinding white fire? The answer is a terrifying, absolute no. Even if we waited an eternity, the sky would still be dark. And the reason for this is the final, most devastating piece of the puzzle. The universe is not just sitting there, it is actively tearing itself apart. In the 1920s, astronomer Edwin Hubble made a shattering discovery. The universe is expanding. The space between galaxies is stretching out in all directions. And here is where it gets crazy. When a distant galaxy moves away from us at blistering speeds, the light it emits gets stretched out too. Think of an ambulance driving away from you. The sound waves stretch, and the pitch of the siren drops. The exact same thing happens to light in a process called cosmological redshift. As light travels across expanding space, its wavelength is pulled and stretched, shifting it away from the visible spectrum that human eyes can detect. The light from the most distant, ancient stars gets stretched so violently that it drops out of the visible red light band entirely, fading into invisible infrared and eventually into microwaves. Now, prepare yourself for the ultimate mind-bending truth. The night sky is actually blazing with an unimaginably intense, continuous wall of light right now. It is called the cosmic microwave background, the afterglow of the Big Bang itself. If your eyes were tuned to see microwaves instead of visible light, you would never experience darkness. You would look up and see a blinding, glowing sky in every possible direction, with not a single gap of blackness. The paradox is real. The sky is completely lit up. You are completely blind to the light. So the next time you look up at a quiet, dark night sky, don't just see empty space. That darkness is the profound proof that our universe has a beginning, that it is expanding at terrifying speeds, and that even the fastest thing in reality, light itself, has a limit. The darkness you see is the shadow of creation. If this journey bent your reality even just a little bit, hit that like button, subscribe to Star Life, and ring the notification bell. We have so many more mind-blowing secrets of the universe to uncover together. Until next time, keep looking up, but remember, your eyes only tell you half the story.